So let's start with thermodynamics. Now, before we define what is thermodynamics, let's take a look at some key concepts like what is the system, surroundings, boundary, universe. Okay, so what are these? So first of all, let's take a look at what is a system. Now, system is a quantity of matter or a region in space on which our study is focused on. Okay, so this is a system, and everything external to the system will be defining as surroundings. Now, the separation between the system and the surroundings, we call it as boundary. So this is the boundary. Okay. All right. Now we will be talking about it later on, that this boundary may be real or imaginary. It may be fixed or it may change. Okay, so we'll take a look at these things later on. Okay, so now we have defined what is a system, the surroundings, and what is known as the boundary. Okay, now one more thing I'd like to add is that boundary is a surface which separates the system and the surroundings. Okay, and mathematically speaking, we say that the boundary has zero thickness. Okay, so it cannot contain any matter and it doesn't have any volume. Okay, now we define the universe as the system and the surroundings taken together. So this is universe. Okay, so the universe is defined as the system plus the surroundings. So now we have to understand that we have used this word universe in a restricted sense. Okay, so we have used the word universe in a restricted sense. So what do we mean by this? So in thermodynamics, when we'll use the word universe, we will not necessarily mean that we are talking about the entire universe and that is everything there is. Okay, so we won't necessarily mean that. Now the question arises, if we are using the word universe in a restricted sense, then how big it will be? Okay, this is one question. How will we choose it? Okay, so to answer these questions, we have to take a look at the energy interactions and the mass interactions between the system and the surroundings. Okay, now if these energy and mass interactions do not change the fact that the energy and mass interactions between the universe we have taken and the outside world is almost zero, then we can say that we have chosen the universe correctly. Okay, so it is like a mini world. Okay, inside a world, it's like a mini world. Okay, which is cut off from everything else. Okay, so this is how we define a universe. Now we come to the question regarding the size of the universe. Okay, the universe in the sense we have defined here. Okay, I'm talking about this. So the size of the universe really depends on the problem you are analyzing. Okay, I'll give you some examples that will give you a clear understanding of this. So let's say that this is a room. Okay, and in this room I have introduced a small steel ball which is red hot. Okay, so this is the steel ball and we have air in the room. Okay, now if I have to analyze the interaction between steel ball and the air in the room, so what I do here is that I take the steel ball as my system. Okay, so this is my system, the air in the room as the surroundings. Okay, and the entire room as my universe. Okay, so I can take the entire room as the universe provided I keep these conditions in mind. Okay, another example can be the entire earth. Okay, this is earth. Earth is surrounded by atmosphere. Okay, so we can have a universe containing the earth as a system. Okay, and the atmosphere as the surroundings. Okay, and we can take them together and call this as universe. If we are analyzing a problem at that scale. Okay, so the size of the universe depends on the problem that we are analyzing. Okay, it's clear, right? So in the next lecture we'll be studying these in detail, like various kinds of systems and all. Okay,